Welcome to this workshop. I think it's a really interesting topic for most people right now. It's exciting because it's the first official hack where we have this API public, that we can actually access the frames finally. We got so many requests in every hack, and we couldn't do some of the ideas because we didn't have this capability, but now finally we have it, and I'm really excited what you're going to do with it. I'm going to talk a little bit about the API itself, how you can use it in Unity, and how you can run your own machine learning models with it. And then Ashray has some more hands-on part. I think we covered that. So I'm going to talk about the basics of the API, how to use ML models with PCA. And then also a frequently asked question is, how do I fine-tune models? Or I want to use a model for a very specific task, which is the reason why you would need to fine-tune a model. And then also very frequently asked is, how do I bring my 2D outputs into 3D? So let's say I have object detection, I have the bounding boxes in 2D. How can I actually show it in 3D? So how can you use the PCA today? I think most of you have seen we have a Unity GitHub repo. It's just a sample project. You don't have to download any specific SDK or OS version. Well, you have to be above 74 at least. Then for Unreal, I know there is some person who wants to do Unreal samples for this hack. We are working on this. It's coming later this year, but right now we don't have any implementation for Unreal. And you can also use it with native Java or Kotlin code, just accessing the Camera 2 API directly, which the webcam texture in Unity is accessing under the hood. And then the same for the spatial SDK, basically, because it's also running on Kotlin. So I wanted to mention the limitations or some frequent questions I get, just sort of to save you some time on this hackathon. We can only access one eye at a time. People want to have the left and the right at the same time. Right now, with the webcam texture, at least, you cannot have this. If you use the Camera 2 API, if you implement it yourself, you can do it. But right now, if you want to switch the eye, you have to stop the webcam texture and then start it with the other eye. We do not have accurate timestamps. And what that means is we do not have a timestamp of when a frame was taken. So we take a frame and it might take 2, it might take 3, it might take 4 frames. We don't know exactly when it was taken. And this is relevant, especially if you do object tracking or object detection. You want to have an accurate timestamp because you want to know in what pose was your camera when you took this image, because otherwise your bounding box will not align. You might experience some crashes. This is caused by Unity. It's not cleaning up the resources of the webcam texture when you stop the experience. So all you have to do is just wait a few seconds before you start the application or before you try to access the webcam texture again. Then also very frequently ask, the PCA is not an OpenXR feature yet, so you cannot use it with AR Foundation, XR Toolkit. These things, you cannot use the camera frame, so please use the Oculus XR plugin. Also, a very frequently asked question, people want to place things very accurately in their space. And the PCA and also our depth API are not really made for that. So you can achieve maybe centimeter accuracy, but if you try to have sub-centimeter or millimeter accuracy, maybe try to go with another library. We're going to see OpenCV in a minute. OpenCV can very precisely position markers in your 3D space simply by using the camera data. In general, be aware of performance impact. Ask yourself, do you really need the camera, or is it just a cool thing to use in your app? Because it can be really expensive to access the frames, every frame. So you basically have 4 ways how you can access the frames in your application. This kind of goes from difficult to apply or needs some experience to easier, but also from very efficient to costing more of your performance, if that makes sense. So you have compute shaders. Most of you might have heard of compute shaders. You can do calculations directly on the GPU. You don't need to transfer any data from the GPU to the CPU, which is the expensive part. What is this? Okay. Shall we further away? Okay. This is good for heavy math or object detection, stuff like that. Then obviously we have shader samples. We have a water shader sample in our GitHub samples. For that you can use shaders or shader graphs. You have an input image, which is your frame, and you produce an output image. Then what is really cool with Unity is that they have built-in GPU tools. So you might have heard of render textures or graphics.blit. Especially graphics.blit is good to know if you want to feed it into your LLM and ask. It's going to be really helpful if you want to copy the camera frames from the GPU to the CPU and do some calculations on there. And then the laziest way, and to be honest, I also use it in my color picking example, is the get pixels. So you can just call webcam texture.getPixels, and you can get the information of a specific pixel. For that, you need to have the texture on the CPU. That's why it costs you a lot of performance to do that. So try not to do this every frame as well. So this is what the community is building at the moment. I'm sure most of you have seen the thing on the top left. I don't know if he's here, Christoph. I don't think so. Bally, he has built a ball tracker. So he tracks the color of the ball using the OpenCV library and using the Quest Camera Kit, which is a repo that I built. The same is on the top right. I built a QR code tracker, which you can use. And also Christoph is tracking objects with it. Then on the right side, further down, we have someone who is using Stable Diffusion. He's running this on his local machine, and he's streaming images from Unity to his local machine and streaming back the image that he produced. On the bottom, we have someone who's using a cloud API. So he's sending the image to the cloud, and he's getting a 3D model back and putting that into Unity. And then on the left side, we have Takashi. He also has his own GitHub repo. This is what I was talking about. He's using the Unity OpenCV plugin. Just be aware that it costs, I think, $90, $95. But you can see purely based on vision, he's positioning the markers very accurately. So he's not using any depth sensing whatsoever here. If you want to check out all that people have been building so far, you can scan this, and also you get the link to the GitHub repo. Okay, so how do we use ML models with PCA? There is basically 3 ways. My favorite one is using cloud APIs. It's very flexible, it's very easy to use. You essentially capture your camera frames, you encode your PNG or JPEG. Unity can send web requests, so you just send a web request to your endpoint, or basically an URL where your model is hosted. This can be Hugging Face, this can be Google Cloud, any other provider, also OpenAI. If it's an LLM, if it's an object detection model, it's most likely Google Cloud or Hugging Face. You get a result back, and then you parse these results in Unity. The big advantage here is that these models are really huge, and you couldn't run them locally on your machine, and you can get very accurate information, for example, bounding boxes, very quickly with good cloud APIs. Here, also make sure that most of these providers let you test their model before. So let's say you're on Hugging Face, you have an object detection model. Make sure that you test it, that it's running, and also that it's running fast, because with models, there's a thing called cold and warm. So some models might be cold because they haven't been used by anyone in a long time or not enough people. So they're cold. So even though the model would be fast, it is hosted on a slower infrastructure by the provider to save costs. So you want to pick a warm model, or what these providers also offer you is endpoints. So for example, Hugging Face has an inference endpoint. And this means if there is a model that you want to use and you don't find it hosted already, you can go through their library and deploy it to dedicated hardware. You will pay a little bit. It can be 10 cents, 50 cents, $1 per hour where you run this GPU. But it's a really good way, and you have a really powerful infrastructure. And I think it's okay to run it for these 2 or 3 days if there is a model that you really need. A disadvantage here is it can be slow. So you have to send the image through HTTP and then get a response back. We will hear later from Ashray why this isn't the best option. Some models are fast, maybe 50 milliseconds, but I'm, for example, working on a project right now where it takes 400 milliseconds, so 0.4 seconds. So if real time is the most important thing for you, you might opt for the next solution, which is on device. Most of you have heard of Unity Centis. It's called Unity Inference Engine now. It's very similar. You just run it locally. And here you have to keep in mind that not all models can be run on the GPU. So for me, this is the thing that's not so great with Centis, is that you have to have some knowledge of machine learning to even run it. You have to prepare your model. You have to not only download it in this ONNX format, but you also have to sometimes clean it up and bring it into the Centis format. And then, even then, as an example, our GitHub samples, you have a YOLO V8 sample, and you might have noticed that it only runs on the CPU, not on the GPU. In this case, the GPU would give us way better performance, of course, but because of the nature of the model, it cannot be run on the GPU. So for me, Centis is quite hard to use, but of course the advantages are that it's fully offline and the latency can be super low. A further disadvantage is that the model that you run is rather small. So you have to use a very tiny model to run it on your device. It cannot be too big, otherwise you cannot run it anymore. So think about your use case. If you need an extremely precise model, then maybe do not go for Unity Centis. Look for something online. If for some reason you don't want to use Centis, there is other alternatives, TensorFlow Lite and ONNX Runtime. They both have unofficial GitHub samples as well for Unity. Then the last one, you can also spin up your own machine. I don't know if anyone has brought a separate PC or whatever with a GPU, but you can also spin up your own server, run your model there, and then connect your Unity client to that server and send data back and forth. You can send data via HTTP, WebSockets, UDP. And again, we're going to hear from Ashray which of these approaches is the fastest. Here, the good thing is you have full control over your stack. You can use whatever you want, whatever framework to run your model, whatever model you want to run. In this case, it probably also cannot be too big because it's sitting on your local machine, but it can definitely be way bigger than a model that you run on your Quest. Well, the only disadvantage here is that you need some experience to do that, and you need to manage your own hardware. But for a hack environment, if someone has experience, this is really a good alternative. So again, yeah, which one is the best? For me, it's cloud, clearly. I'm working most with cloud. It depends on your task and your use case. For LLMs, I would say it's clearly cloud APIs. They're so fast nowadays. They're as fast if you would have them locally. Think of using the OpenAI API or Amazon Bedrock. If you go for this, think about using their APIs. By the way, in the Quest Camera Kit GitHub repo, I also have a sample for OpenAI LLM. So you see how I use speech-to-text, their speech-to-text model, then their normal LLM model, and then a text-to-speech. So the full workflow is only done by calling their APIs, like a chain of APIs. So training or fine-tuning ML models. Why would you need to fine-tune a model? Sometimes I get questions, especially frequent is a question where people want to do some kind of sign language detection or whatever. So if you have this idea, please don't do it. We have it so many times. But if you think of it, you wear a headset and you look at your hands from your point of view. There isn't really a model out there that is trained on it. Like there is models that are trained on sign language, but from a third party perspective, not from someone wearing a headset. So if this is really what you need, you would need to train your own model on your own images because this model doesn't exist yet. So you have to feed these images to a model and tell him, hey, this is this sign and so on. This is for object detection, but also the same goes for LLMs. Let's say we take one of our sponsors, Puma. You want to do an instruction on how to repair your shoe. GPT-4 or 4.1 is really intelligent, but it cannot give you really the correct answer. It will hallucinate, and you can feed your instructions in your prompt, but then you always have to include additional instructions in every prompt that you give the LLM. So what you can do is you can actually fine-tune GPT-4, and fine-tuning just means you're continuing the training on a pre-trained model. So 4.1 is an already trained model, and then you're just going to continue the training with a smaller subset of data. So we're going to quickly look at how this looks like. If your use case is more like object tracking, I really recommend RoboFlow. It's super easy to use. You just create your new project and select object detection or any other task. And then you can upload your images. Of course, there's already millions of models that use dog images, but I still use dog images. You upload your images. You can select even more images from their own library. You can even upload videos and so on. The next thing, what you need to do to create a model is to label that model. So you need to tell your model what does it see on this image. So either you can manually drag, make a square and label it, puppy, or they offer you a service to do it automatically. And they even have a service to outsource it to actual people who then label data for you. To get a reliable model, you would need ideally a few hundred images. But for prototyping, you might get away with a few dozen images. This service is really great because after you have labeled the images that you uploaded, you get a hosted API. So this string up here is the endpoint that you call in Unity. And then you get the output here, which is your bounding box, and the class, which is dogs. And the confidence value, 0.692, means it's 69% sure that this is a dog. With RoboFlow, you can not only use cloud APIs, you also have a tab on device. You can even run it on a Raspberry Pi, on your NVIDIA GPU. So there's a ton of deployment options. If you don't find your object detection model, consider using RoboFlow. And then lastly, you can do the same for large language models, OpenAI. You go to your dashboard, fine-tuning, And then you can select a method, supervised. Supervised just means that you're feeding your model with labeled data. And then you can select a base model. So the model that your additional data is going to be based on, or the model that should learn your additional information. You give it a name and then you upload your data. And the data is in the format of questions and answers. So you give a lot of questions and answers to this model. So how do I repair the sole of this and this shoe? And then you give the answer to it. How do I repair the lip of this model of shoe? And so you can give it a lot of very specific information. And I think this can be really helpful for some of you if you have a very specific use case, especially with our sponsors here. Last part is how you bring your 2D outputs into 3D. First of all, I would encourage you again to check out the Meta official pass-through camera API samples on GitHub. In our implementation, we have the pass-through camera utils class, and it comes with many helper methods for you. So you can, for example, query the resolution of your image, your whole camera intrinsics like focal length, principal point, resolution of your sensors. You can get the camera pose in world, which is very important. We're going to look at that in a second. The 3D position and rotation of your camera. And then if you want to place something, you will need to raycast into your actual space. And for that, you can use screen point to ray in world. This is going to construct a ray. And then using our environment raycasting, which comes from the depth API, you can feed that ray into the raycasting method and get a precise hit point in the world. We're going to look at that right now. So I'm going to talk about two ways, and these are the two last slides. So first from 3D to 2D, and then from 2D to 3D. Both of these samples are in the Quest Camera Kit repo from me. First is the color picker, and we start by picking a 3D point in our world. So we use the Environment Raycast Manager, which comes with the core SDK. And in the raycast method, we put our ray and the direction of our ray, so forward, for example. And this is our point in the world. So I want to sample this point, which is going to be black. And then we have to transform this point into the camera space. First in our world space, and then in our local camera space. And by querying the camera intrinsics, we can then align our image with our camera sensors. And by doing that, we can align the point that we sampled on the 2D texture where that point is on our sensor. So when we have that point, we can then call the getPixel method from webcam texture and texture that exact pixel on the coordinates that we get from our calculation here. Again, there is one simple class for it in the GitHub samples in the color picker example. So the more interesting use case is you have a result from your machine learning model, bounding box, for example, and that comes back usually in a very specific format. So most machine learning models, they don't just take any format, and they also don't return any format. So in this case, it's returning 640 by 640, but we know that our camera has a format of 1280 to 960. So please keep this in mind. Many problems stem from this wrong conversion. So we have to scale these results that we get back to the actual size of our resolution or our sensor to line them up. And after they have been lined up, we can construct the ray from our helper class and then use that ray to kind of shoot a ray to that point in our headset into the real world. And this is how I placed these bounding boxes in the GitHub repo. Yeah, I hope this was not too much. We have a little bit more time. We're just gonna give it to Ashray, and then we have maybe 20 minutes, even half an hour for questions.
All right, guys. So I'm gonna take over, and thanks a lot, Robbie. Thank you, guys. Okay, we'll skip this. We don't need introduction. So from Robbie, we heard the theoretical part, right? Like how to do it and stuff like that. So we have been planning this for a month now, and before XRCC, I wanted to see what are the 3 ways in which we can use AI and use it in XR. So the first way is to use it using Flask, which is like you're setting up your own local server, hosting your AI model there, giving your input from your headset to your local server and getting a response from it. So that's step 1. So the second one is to use an online API like Google API, there's Hugging Face API, there's so many out there. So that was my second task. And the third one is to use a local in-headset system that, for example, Centis, that can process the AI models and give you a result. So there are 3 ways in which it can be done, right? So let's have a look at them one by one. Now, ideally, I would want to have hands-on, but then I realized that it's going to take a lot of time. So I've done the project. I'll share the resources with you. I have the documentation, my brain dump, all those things are there. You'll see it later on, and then you can download the project and mess around with it however you like it. Okay, so the first step is to use AI and XR using Flask. Okay, so there are a lot of things like I could do, and I wanted to try body pose estimation using MediaPipe. Now, the first question for you guys is, how many of you are familiar with Flask and Python? Raise of hands. Okay, not so many, but yeah. The thing is, for those of you who don't know, Flask is like a Lego block, but like how you know building blocks, similarly Flask, you can build your own servers where you can host your server and then you can send a response to the internet and then it'll process and send it back. So it's as simple as that. Now the next question for you might be, I'm an XR developer with no Python knowledge. What do? I hope you recognize these symbols, right? Yeah. So it's a hackathon. You don't have enough time to learn everything from scratch. Use these AI models that are there and then make them do the research for you. But you need to have at least some knowledge so that you know how the Flask is running, how the program is running. So if something is messing up, you know how to fix it. And for that, what I've done is I have documented my prompts, and you can go through those prompts and see what it does, how it's set up, and you'll get all my brain dumps and things that are there here, and you can use it, and I'm pretty sure it'll help you. Now, going a bit technical so that you understand how it works. How does the Flask app work? Now here you'll see that we have like a program, and the most important part is the detect object function, right? So this function, what it does is whenever you click an image from your headset and you send it over, it is going to first convert it into a type or a data type that Python language can understand, and that's done with something called as PIL library, that is Python image library. And then once you have it, we need to convert it into a format that MediaPipe can understand. And that is nothing but a NumPy array. And once you have the format that the model can understand, you can use it for processing. In my case, it's going to be a MediaPipe processing. In your case, it could be any other model. I will show that as well. And then finally, once it's done processing, it's going to give you a result, and you need to extract whatever data you need. In my case, it's going to be an X, Y, and Z position. Maybe some models will give you a bounding box as well. You can extract that values. So it's up to you. The next question is, what if I want to use another AI model, right? So in the Flask app, the first step would be model initialization. Let it be MediaPipe, YOLO, or any model that you find online. You need to initialize it. And how do you know how to initialize it? You have to check out the documentation. And then the rest of the steps remain the same. You process the image into a format that the model accepts. You process the AI model, and you process the output that you get from the model and use it for whatever use case you want. So how do I choose the AI model? So when I wanted to do body pose detection, I had some time. So what I did was I went online, I looked at all the body pose detection models that are there. And there were 2 models that stood out the most. One was YOLO and one was MediaPipe. Now, how did I choose that I wanted MediaPipe and not the YOLO model? Well, basically, it said that the YOLO model gives me 17 key points for the body parts, whereas the media pipe was giving me 33 points. So I could track the eyes, face, hands, legs, all of them. So that's how I chose my model. So you guys, based on your use case, you'll have to see what fits best for you, do your research and choose the model. Now, since once again, it's a hackathon, you will not have so much time to go into the documentation. So put AI to use. So I think OpenAI, Grok, all of them now have deep research. So make sure to write a good prompt and ask the AI to research it for you and make a summary, and you can decide the model that you want to choose. All right, so now that we have seen how Flask works, the next question is, how do I send the image from my headset to my Flask server? This is pretty simple actually. Step 1 is to capture the image and do the pre-processing. So I'm assuming we are using Meta headsets and they are helper classes. So we are using the webcam texture to get the texture of our headset. In my case, I'm capturing the whole texture. In your case, you can have other stuff as well, like a pinch and zoom, or you can drag and drop. So it doesn't matter, but you need to capture the image somehow. So once you have captured the image, the best thing to do is to resize it so that it can be more efficient. Now, if you're wondering, how did I get 640 cross 480? Well, that's the media pipes format. So they say that only if you give me the image in 640 cross 480, I will process it. If you give me a larger image, I'll throw an error. So look at the documentation and make sure that the size of the texture is matching the size of the model. The model, whatever it's accepting. So this is step 1. You've captured your image, you've pre-processed it. Now, the next part is important, which is client-server communication. Here, I'm using HTTPS requests. I'm using Unity's library called as www-form. And this basically is a helper class that lets us take the image. So you're giving your file type. Now, image bytes is obviously going to be like the byte data. And then we're giving our image name and the type of image. In my case, it's a JPEG image. And then we send the request to the server with the data, and then we wait for the response. So once we have the response, you process it. And I'll show you how the processing works. Yeah. So from the Flask app, we are going to get a JSON response, which we are going to then parse and extract the key values. So in this example that you see here, you might notice that this is not exactly 3D. It's like on a canvas. I hope you can see it here. So this is where the next step comes in for you. Is like, would it be possible for you to map this from a canvas to a real person? Well, sometime back I had this discussion with Robbie, and to be honest, it's not possible because in this case, what you would generally do is you would send a depth raycast from your headset through the canvas to the person, and having so many points running at the same time, your headset will die. So this is just an example, but yeah, you have to think this through, like, is it really possible? Maybe not. All right, now there are some things that you should know. In my Flask app, I used HTTP request, right? But it is better to use WebSockets. Why? Because they're much faster. So with the HTTPS request, what happens is every time you send a frame, it's going to make a new connection, which is going to add on to the latency. And the other the other disadvantage with HTTPS request is that you can send one frame at a time, right? So if your server is slow, it means that all the frames that you send are going to get processed one after the other, and then you're going to get it like later, and there's going to be a lot of latency. So the advantage with WebSockets is that it is a persistent connection. It's like a food truck, basically. It just comes instance, you sense the data, and it goes back and forth. It's much faster. Then the question really is, when do I use HTTPS request? It depends on your use case. So let's say you are having an AI model that has to be really reliant. It could be probably a medical scenario where you are trying to find out, I don't know, just an example, like some example where you want it to be reliant, where you don't want it to skip any frames. That's when you use HTTPS request, and you make sure that your server is running fast so that you get the response early. And then let's say the other thing that you should know is, if you're using HTTPS request and it is not so important, then you can always have logic in place that will skip some frames so that it's processing faster. And finally, you can tweak the confidence score. So all the models have a confidence score. So based on your requirement, you need to set your confidence score, sometimes 50 to 80%. So in the Flask app that I created, when I had set it to around 50 to 60, it was not detecting any of the body points. I'm not sure why. And then once I increased the confidence score, it started detecting. So whenever you're using a model, if you see that it's not working, just try to increase the confidence score and check if it's working or not, and that could help. So what's the biggest advantage of using a Flask app? You can run a large AI model, but you'll need a more powerful machine. And second thing, it's free. Like, it's running on your laptop, and it's not costing you anything. All right, now let's move on to see how we can use Google API. So here I wanted to try OCR translation. Like, first it detects the image that's there, and then it's going to translate it. So what you're seeing here is called developer art. Please don't judge me on my canvas and text. So that's how developers are. And yeah, so how this is working is like very simple. So the question is, how difficult is it to implement it? Easy peasy. All you need is a script that detects the text from the image, a script that translates the detected text, and then one more script that takes the picture and uses the about to scripts. I'm going to go one by one and tell you how the scripts work. So for text detection, first you need to declare a structure. In my case, I've just selected a text, but in your case, you might want to extract the bounding box and maybe the detected language code, right? So you declare the structure, then you process the image and the texture. Once you have the processed image, you send it to the Google API for detection, and that will send you a response, and then you parse it. All right, so here for processing, this is general script. Again, you'll find all of this in the Notion package that I've created. Yeah, so here you can see that when I'm processing the image, I'm changing it to base 64 string. How do I know that it's a base 64 string? The documentation. So make sure to check the documentation and see what is the format that is requiring, and based on that, you'll have to process your image. All right, so so for using the API, you need to create a request, and this is a feature of text detection. And then once you have the request created, you're going to send it to the Google API. It's pretty simple. Now here I'm using the Unity's HTTPS, what's it called? Net.http package. Now this is different from the www form that I used initially. This is more modern and it is better for processing JSON. So I would recommend using this one and not the www form. All right, so once we send the image to Google, it processes it and it gives your output. You're getting your output, and finally you're going to pass the result. And like you can see here, I'm detecting just the text, but it is going to give you the bounding box and the annotation as well. And if you want to use the data, you can. Now, the best part about using Google API is it has many features. So let's say you don't want to do text detection, right? You can just change the text detection to any of these. It's like using OpenCV basically. So you can have face detection, you can have landmark detection, anything that you want. So just by changing one line, one word maybe, you can choose the feature that you really want to use. Okay, so initially we started with text detection, right? You see how I declared the structure, because text is going to give me text, a bounding box, and language. But if you choose face detection, the structure is going to change a bit. You're going to have a bounding box, you're going to have confidence, it'll give you an emotion and landmarks. So once again, you'll have to look into the documentation and see the output that you're getting. And based on that, you need to define your structure class. All right, so this kind of gives us an idea of how you can take a photo, send it to Google, and get the text from it. What is the next step? Is the text translation. Now, this is also same thing, very simple. You declare a structure. So I need a text, and then you send the text to API for translation, and then you pass the text. So here's the result structure. And yeah, again, I'm sending a request to it using JSON request, and we wait for the response. We get the response, and then we finally pass it. And the last part of this project is to have like a manager script that will use both text detection and translation together. And how this works is, first, we're taking a snapshot. Like once again, I said, right now I'm taking a snapshot of the entire texture. You can use your hands to drag and drop and things like that. So once you have that, I am sending it to the text. So it's going to detect the text, whether it detects all languages. I tried it with French. I think if you are using Japanese or Korean, you need to download a specific Text Mesh Pro asset, because it just shows you some boxes, but on its other languages, it works fine. And once I get the text result, then I'm sending it to translation. And once I get that result, I am going to display it on my canvas, which is over here. So I'm displaying the detected text and then the translated text. All right, so we saw how to set up local AI models on local using Flask. We saw how to use the Google API. And now let's see how to do it on device using Centis. Now this is again very simple, and this is a sample project that you can download. Robbie already spoke about it. It's really simple. Now, Unity Centis generally runs directly on the headset. Now it is perfect for XR application because you don't have to rely on servers, or you don't need to have internet and things like that. But the only problem is that you need to somehow maintain the 90 frames per second standard that's there. So that's the challenge we have. Now, here are some of the key components that goes into building a Centis AI system. So we need a model asset, which is going to be the Onyx model. And then next thing you see that the backend type is CPU. Now, for object detection, for some reason, it needs CPU and not GPU. So I'll ask Robbie to talk about it.
Yeah, I mean, I basically already mentioned it. It's based on the model. If you use YOLO V8, there is also a YOLO V8 model from Unity. You will see it actually works with GPU backend, but the YOLO V9 model that we have in our samples, you can't use CPU backend. And we just found that out through trial and error, because Unity doesn't really document that, but it depends on the model. So just try both, and if one of them doesn't work, the model doesn't support it. I don't exactly know how to check it if it does support it. The reason why we used YOLO V9 is because of a licensing thing. So YOLO V8 was under licensing. That's why we didn't include it in our samples. So we had to go to YOLO V9. That's the only reason.
Yeah, so basically you need to check and see. Sometimes it works with GPU, sometimes it works with CPU. So it really depends on the model of your choice. The next part is the model loading and inference. So how it works is Centis handles the Onyx conversion by itself. So that's magic. So worker here is essentially like interface that you can use for processing your input that you're getting. Now the pro tip here is that whenever using Centis, you should initialize the model during the you should initialize it during the initialization process and not during the runtime, because then you can see frame drops. All right, and yeah, so the final part is the 3D bounding box creation. Now this is where the magic happens, and this is where like the XR comes into picture, right? So traditionally 2D computer vision just gives you the X and Y spot. Now using Centis, you will get X and Y, and for us, what we have to do is we have to use the raycast and show the raycast to those points, see which point it hits, and then you get the 3D space, and that is where you put your marker. And that is how the object detection works. All right, so we will give you all these resources in the Notion package. I'll put it on Discord and send an email as well. And you can play around with all those. It's a GitHub repository.
My question would be, as I know, there are plans on releasing pass-through API for WebXR. Do we know like when that's going to be? Is it planned this year?
WebXR, you said?
Yes.
There's currently not any plans that I'm aware of to make it available for web. So yeah, I can't really tell you.
Thank you.
But Unity, Unreal, Spatial SDK is going to happen soon.
I guess I'll find you later because of Unreal. I had another question. Rob, you mentioned that you should sometimes fine tune the model to use it. And that made me think of a very popular approach nowadays, RAG, the RAG, Retrieval Augmented Generation. So you use an existing LLM and give it the ability to look up files in real time. Do you know of a way to do this, like locally with a server or on headset?
Look up what, did you say?
So you basically you can attach a lot of text files and the LLM goes through it to respond to your question.
Have you checked out embeddings, OpenAI embeddings? That would be my guess to create embeddings with the OpenAI API and go through data like that.
So that would be like an API.
Exactly. Yeah, they have their own model for it. You can just call it with an API as well. Yeah, I don't know how long it takes. I have never tried it, but yeah, embeddings.
Really cool. Thanks.
Yeah.
My question is on behalf of all the curious minds. Is there any workaround for the timestamp? Like, did you plan to? Have you done some tricks to make it work?
Yeah, I mentioned that we're gonna bring it in the new API.
Will it be available for the hackathon?
No. Well, if you use the underlying Camera 2 API from Android, you can do it, but you have to do it yourself. I think Christoph is gonna be here. Christoph Spinger, who did the ball detection use case. He did that. You can talk to him.
So I'm planning to create my own input device for like a controller for the headset. So what I was planning on is having a pattern on the IR pattern on the device to track where it is spatially. So what do you recommend? How do I go about it?
You see your device and you want to highlight something on the device?
It detects the position and there's a gyro sensor on the device. So it gives you the position, gives you the, placement of the device.
Yeah.
And you detect the position of the device through the pattern on the device, like it happens on the remote, on the XR remote, on the Meta remote. So what do you recommend?
Again, can you ask the question? Like you have the Quest and you have your own device. Like
I am making my own device. It's under process. Okay, so I am planning on putting a pattern. In our remote, in our official controller, there is a IR pattern on the remote which detects where the remote is, what is the position in the spatial this thing, and additionally with the gyroscope, you know how it is oriented.
Yes.
So a very similar approach I'm planning to do. So what do you recommend me using to get the position of that device?
Yeah, I mean, I would solve it from a hardware level, but I'm not a hardware expert at all. So assuming that you don't solve it on a hardware level, you just solve it visually in this sense, right? You would need to use a marker. I mean, the marker is your best bet. You've seen the OpenCV use case, I think. OpenCV is great for that. I wouldn't recommend using the camera access with the depth API because it's not going to be accurate enough to hit your device from your headset. So you would need to use something like OpenCV or MediaPipe to.
Can I use Vuforia by any chance?
I don't think so. I think it relies on OpenXR or. I'm not too familiar with it. What is the underlying package? But
okay.
I do need to use Oculus XR plugin too.
Okay. So the earlier I tried doing it using the hardware as you recommended, but then the problem I faced is the localization. So I don't know the initial position of the device. For me to do it on, basically the hardware part is used to correct the problems. Like it's always used in tandem. That's the reason you have markers on the controller, on the official Meta controller. So yeah, I'm just trying to wrap my head around for a while. I just skipped the project for a while and then the pass-through API popped up and then my head started running again about it.
Yeah, I mean, in context of this workshop, you could only track it if it's visible to you.
Yeah, it'll be visible throughout. It'll be visible. If it's not
Okay.
visible, then I'm not tracking it.
Yeah. So yeah, that would be my best guess with markers, but not with QR codes, not with depth, but using a proper OpenCV or computer vision library.
Okay, thank you.
I think it could be helpful, but Google just released a paper last October. If you search for XR objects for Google, it's an open source GitHub that make a 3D object detection based on MediaPipe and Cuckoo.
Mm-hmm.
So I didn't honestly tried it, and I don't know how much it's compatible with what you mentioned, but it's mainly for augmented reality. So
yeah, I mean, I guess that's what Ashray showed with MediaPipe and what we've seen with OpenCV. There's some models that are capable of placing things in 3D space solely based on visual.
We have like a special track from Puma which is just related to AI and not exactly XR, right? So if you're interested in it, then I would ask you to check it out. But the thing that they want to do is they want to see if users can generate their own shoes and add textures to it. So I'm just going to show you some research that I did, and so basically ideally you would want to have one AI generation tool, or maybe you can have APIs from different tools. So the objective is for the user to generate his own shoes, add his own texture, and then maybe 3D print it. Okay, so during my research, I tried to give it a prompt to generate a basketball shoes, and then you see it's not so good. But the biggest challenge for me was to give the texture of the existing shoe and change its texture, right? So what I did, I tried to send this image to DALL-E and be like, hey, check out all the colored parts and change the texture. But it does not do it, because it really does not know like which are the colored parts, and some of them are black and blue. And I mean, finally, the last part that I had to do was I had to manually choose the texture using Blender, and then I have the shoes, and then I give it a prompt like make a flame pattern, and then it generates the image. And then when you click on apply, it applies to only those part of the shoes that is black, if you know what I mean. Like it ignores all the other stuff.
Okay, here I just want to add, please don't do it like Ashray and type it in with a keyboard. Just use voice input. So either use the OpenAI voice to text model, or use the voice SDK from Meta. Okay.
Oops. Sorry, guys. Yeah, so this is how you see, like basically it's taken only that part of the texture and added to it. So if you guys like in this hackathon are interested, you can see how you can solve this issue. Like, and we have again documented this in the Notion page. So check it out. All right. Thank you so much.